Here we are with another video, and I have some exciting news for you guys. This video, we have the return of the purple pen. And this purple pen's not alone. We have a whole set of these. Look at these. So I couldn't just get one, I had to get a whole set. So no longer are we going to have these nasty, useless, dull pens. We have the pen, the purple pen, along with its nice little family. We are looking at the sum and difference identities in this lesson. So is this true? If I took the sine of 45 plus 30, is it equal to the sine of 45 plus the sine of 30? Well, the only way to test this is to use our graphing calculator at first. So let's see. Let's say, we're in degree. So let's make that change with our calculator in mode degree. So sine of what will be 75. Sine of 75 degrees, we have 0.9659. And then sine of 45 plus sine of 30, we get 1.2071. So they are not the same. This is kind of the same concept of saying the square root of 4 plus 5 is the same as saying the square root of 4 plus the square root of 5. And we know that that's not true. And we see that that kind of same thing happens here. The sine of 45 plus 30 does not equal sine of 45 plus sine of 30. So what is it? What would the sine of 45 plus the sine of 30 actually equal? What is its identity? So we have three identities to share with you today. The first is our sine identity. So sine of two angles, we'll say theta and beta. So sine of theta plus or minus beta will equal sine of theta multiplied by cosine of beta plus or minus the sine of beta multiplied by the cosine of theta. So something with this sine identity is that if I'm adding the two angles, I'll be adding these two pieces. If I'm subtracting, I will be subtracting these two pieces. That's what the plus minus means and how they're organized. So if I gave you the cosine of the sum or difference of two angles, so theta plus or minus beta, with the cosine identity, it is cosine of theta, cosine of beta. So we're multiplying cosine of the two angles, and here the sign switches. So it's minus plus sine theta cosine sine of beta. I said that wrong. So we have cosine theta, cosine beta, minus plus sine theta, sine beta. So if I'm adding the two, we are subtracting this set. If I'm subtracting the two angles, we're adding the two sets, so the signs switch. And then our tangent identity. So the tangent of the sum and difference of two angles will equal tangent of the first plus or minus tangent of the second divided by 1, here the sign switches, tangent of the first multiplied by tangent of the second. So a couple of things. So the sine, if I'm adding the two, we're adding the top but subtracting the bottom. And the reverse could be said if I'm subtracting two angles within tangent, that we're subtracting but then adding in the denominator. So these will be the angles that we'll be focusing on in this lesson. So let's say we had cosine of 15. I want to evaluate that. So cosine of 15, using our identities that we just now see, this is the same as cosine of 45 degrees minus 30 degrees. Okay. So using the identities, so the cosine identity, it's cosine, cosine, sine, sine. So we have cosine of 45, cosine of 30. With cosine, the sign changes, so we're adding sine of 45, sine of 30. So using our knowledge of the unit circle, cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And then we have plus sine of 45, sine of 30 is 1/2. So now this is all simplifying from here. So we have the square root of 6 over 4 plus the square root of 2 over 4. And they have a common denominator, so we can say, oh, it's square root of 6 plus square root of 2 over 4. And that is the value for cosine of 15 degrees. So now about the sine of 105. So the sine of 105, we can identify this as sine of 60 degrees plus 45 degrees. So the sine rule, it's sine, cosine, and the signs are the same. So we're adding here, we're going to be adding in our process. So sine of 60, cosine of 45, signs are the same. Sine of 45, cosine of 60. And using our unit circle, sine of 60, square root of 3 over 2, square root of 2 over 2, and then square root of 2 over 2, and then 1/2. It's looking very similar to what we just came with. Square root of 6 over 4 plus square root of 2 over 4, which is square root of 6 plus square root of 2 over 4. Again, this is the sine of 105. So just knowing the correct identity and just plugging your numbers in. So let's see what else we have. What if we had tangent of 11 pi over 2, or 11 pi over 12? So I need to think of this 11 pi over 2, I need to think of it in terms of tangent of, I could think of a difference, but it's going to be easier to think of this as a sum. So some angle out of 12 plus some other angle out of 12. We only know, or familiar with, see, out of 6, out of 4, out of 3, and out of 2. Thinking of our unit circle again. Now, if I did, what I'm looking for is numerators that add to 11 still, but yet these will simplify to something I can deal with. So if I did 1 and 10, 1/12, I'm not going to be able to work with. So 2 and 9, I think that's what we're going to go with. So we have 2/12 and 9/12. So it would be tangent then of simplifying pi over 6. Simplifying, that would be 3 pi over 4. So the tangent identity is tangent of the first plus tangent of the second. So it'd be tangent of the first angle. The signs are the same. Tangent of the second angle. Now it is in the denominator where the sign changes. So we have 1 not plus but 1 minus. Tangent of our first multiplied by tangent of our second. All right, so let's simplify and work this out. Tangent of pi over 6, that is square root of 3 over 3. Tangent of any fourth is 1, but this is going to be in the second quadrant, so this is -1. And then we have 1 minus, again, square root of 3 over 3, and again, -1, which simplifies to square root of 3 over 3 minus 1, and then 1 plus square root of 3 over 3. Now, there's a couple of different routes I could take ending this. What I could do, and this is actually this may be a new trick for you. I noticed that the denominators of my fractions are the same number, 3. I could get a common denominator on top and bottom, add and multiply by the reciprocal. That's one approach. Or if we multiply by that denominator with top and by bottom. Watch what happens. So if I multiply this first fraction by 3, it just becomes square root of 3. And then we have minus 3 times, or minus 1 times 3, or just minus 3. And then 3 times 1 is 3, and then the second piece, the 3's will cancel, giving us just plus square root of 3. Now that's a lot cleaner looking than having the fractions in the numerator and in the denominator, and we would say that this fraction exactly equals tangent of 11 pi over 12. So this technique to get rid of fractions can only be used if the denominators in top and bottom are the same. Will that only work for us? So we might see this again, we might not, but just know that you can use that technique to get rid of the fraction. So it's next. Write the expression as the sine, cosine, or tangent of an angle. So I'm looking at this, and this is kind of set up as one of our identities. It's nothing here, I see tangent, so we know it's not going to be tangent. In cosine's identity, it was cosine, cosine, sine, sine. So again, there, we're not going to be using it. So we have a sine identity. So the sine identity was sine of the first angle multiplied by cosine of the second angle. And the sine was the same because it was cosine that switched. So here I could say that this expression I could write as sine of 42 degrees minus 17 degrees, which simplifying would be sine of 25 degrees. So looking for the characteristics of the identity and then working backwards to get the single angle. And we have sine of 25 degrees. So evaluating this would be the same as evaluating this single trig function. Moving on. Let's see what we've got now. Find sine of x minus y given the following. Okay, cosine of x is negative 3 over 5 within this interval. Okay, and tangent of y is negative 8 over 15. And so one thing I foresee us having issues with is these are not common fractions, so we're not going to be able to easily use radians at all. So let's say that our tip here, the tip to approach this, is to draw a reference triangle. Draw a reference triangle. So we're in the third quadrant for x. Cosine, it's negative 3. And the hypotenuse would be 5, being cosine. Okay, so that's angle x. And then for tangent, we are in quadrant 4. So that would be tangent's opposite, so yeah, negative 8. And then adjacent's 15. All right. So we know reference triangles, we need to find the third side. If we do not know, this is a Pythagorean triple, which means that if I take 5 squared instead of equal to y squared, or this length, plus 3 squared, we'll get 4. And the same can be said here. If I did 15 squared equals, we'll put just, I don't know, h for hypotenuse, squared, plus negative 8 squared, we'll get a whole number. So we will get actually that this is 17, which is good. I mean, having a radical isn't that bad, it just makes things a little messier. All right, so we have that. So now having all 3 sides, we might be able to continue here. Okay, so sine of x minus y, using our identity, would be the same as sine of x cosine y. Sines are the same. Sines are the same. Sine of y, cosine of x. Okay? So now we can find the cosine of x, or sorry, the sine of x. Sine of x would be 4/5. Cosine of y would be 15/17. Sine of y will be -8/17. And then cosine of x is -3/5. And we simplify. So we get 60 over 85. And minus, yet this would be a positive number, so still subtraction, 24/85. So they're already common denominators, so we can subtract them and say that this is equal to 36/85, and that is sine of x minus y. It's not bad. We didn't know the exact radian measures, but we used a reference triangle to get our answer. And ending. Yes, ending. This is going to be a shorter lesson because this all comes down to just using your identity. These sum difference identities are very easy to recognize because you're taking the tangent, cosine, or sine of a sum or difference. So we're ending with a verify. We cannot have an identity video without a verify. So verify that tangent of x minus pi is equal to tangent of x. So I could do this a couple of ways. So I'm trying to show that this will equal to tangent of x. So using our tangent identity, okay, so tangent identity, it's tangent of the first angle, and here's the same sign, so still minus, tangent of the second angle, then 1, sine switch, tangent of the first, multiplied by tangent of the second. Okay, so if you do not remember this, go back to the beginning of the video and take a look at it. So simplifying it, so tangent of any whole number pi. So here we have 1 pi. Okay, if I had 27 pi, it would come to equal the same thing. Tangent of any pi is 0. So 1 plus. Okay, so subtracting 0, it's still tangent. 1, so 0 multiplied by tangent is 0, so we get 1 plus 0, and I should have the equal sign on this side. That doesn't matter. Tangent of x, and there we go. Using our identity, we should have tangent of x minus pi equals tangent of x. And that is all. So I wish you the best of luck with practicing this further, using this on other angle measures and using this to verify more identities. So I'll see you in the next video, and good luck again in the practice problems.